Hello, F-sharp. Welcome back. We are continuing our series on introducing you to F-sharp and the wonderful features that it has. This is yet another video talking about functions, and that's because functions are such a critical building block for what we do in the F-sharp language. Specifically today, what we are going to talk about is higher ordered functions. Now that might sound a little scary, but in reality, a higher ordered function is just a function that takes another function as a parameter. Now, later on, we're going to see how they are used extensively when working with the collections in F-sharp. But for now, I just want to introduce you to how you recognize that something is a higher ordered function, how to define your own, how to work with them, and how to understand them. So we can have the simplest function of all. Let my adder takes an A and a B and returns an A plus B. Fantastic. Not a whole lot going on there. Now, let's say that we wanted some more complex logic to go on here. So let my validator, and this is a function, and what it needs to do is potentially several different things. But at the end of the day, we want it to be able to say like, hey, this is something that's going to take an integer and I want it to return a true or false. So let's say that we could write some code here by hand where we say like, hey, if A is greater than 10, then true, else false. Okay, well, we could do that. And at the end of the day, that's pretty simple logic, but let's say that this is going to get more complex and like, hey, well, the validator, like, it's not just doing validation. We need to do some other things as well. Like, let's say like, hey, if A is greater than 10, then we needed to do some additional piece of logic. It's like, okay, well, say like, okay, well, what is this additional piece of logic? They said like, okay, well, potentially there is like really complex logic here. And yeah, well, we could potentially like write this really kind of complex logic for doing some other kind of reporting or something inside the validator. Let's say like, hey, when we hit these cases, we wanted to, log some information or some other kind of some more sophisticated piece of logic than we would necessarily want to put in here. I'm not saying that's a good idea from a design standpoint. I'm just coming up with a scenario for me to use a function as a parameter. So like, okay, well, I'd really rather not write a whole bunch of logic in here, but I do know I want to take some kind of action here. So what I could do is say like, you know what? Let's gonna say like, hey, I'm gonna define a true handler. And this is something that takes an int and does nothing with it, but it's like, it's going to take some form of action with it, right? And so what I can say like, hey, I have a true handler. And what does that mean? It's like, well, true handler is a function that takes an int and returns a unit, which means in this case, it's like, it's not going to return a value. And so I want to call that here, true handler. I'm going to pass in A. Okay. And I'm actually going to kind of break this out. Well, I'm not going to leave it like this. So my validator function now takes another function in order to do the work it needs to do. It needs some kind of true handler. Like, hey, I need you to perform some additional action for me. I don't want to embed that logic inside of my validator. So how would I then call this? I need to give it. So let's say, for example, like, hey, let my true handler, it has to take, and I'm going to give this a different name just so you don't get them confused. It has to take an integer, and I know it returns unit. And do you technically need to do this? No, but like I know the type, so I'm putting it in the function declaration so that the compiler knows what I'm intending to do. And again, I'm just going to do something very silly, but imagine that something more sophisticated here is more sophisticated is happening here. So I'm going to say hit true handler, and then I'm going to say, print out the value. Okay, so now I have a function which has a signature of int to unit, which happens to be the same as true handler. So now if I wanted to, I could say like, hey, my validator, I'm going to pass my true handler as the function into this other function. So now this, my validator is taking a function as an input, and then I'm also going to give it a value of 10. So let's go ahead and find this, get that in there. And now I'm going to call my validator with the my true handler as an input function for my validator and saying like, hey, 10 bool false, it was not greater than 10, so true handler did not get called. But if I put in 20, true handler did get called and says hit true handler 20. And so this is an incredibly simplified example of what a higher ordered function is. My validator is a higher ordered function because it is a function. Whoa, what happened? It is a function. My validator is a function which takes another function as a parameter. And then we can expand this, like, oh, we have like the true case. Now I'm going to kind of tab this out to make it a little bit easier to follow. This is very common for me to do. Well, we also have a false handler now, and you need to be able to do something with the false case. And so now when I'm trying to call my validator, it's giving me an error now saying like, hey, I'm expecting another function here. And I can say like, hey, let my false handler x int. Again, it's going to return unit. Again, you don't have to necessarily do this. You could just do this. I'm doing it just to be very explicit about the type signature. You don't need to. Print function, and then hit false handler. And then again, put an X here. So now I'm going to pass it my false handler. So I'm going to go ahead and put these into interactive. I have defined the function. Oh, but I forgot to actually use false handler in here. So now I'm going to say like, hey, false handler A. So let me go ahead and do that again. I'm going to define these functions in our interactive session. And now when I call my validator is a function which takes two other functions as parameters. And so when I pass in 20, it's like, yep, hit the true handler. It prints out hit true handler and the value of 20. And then if I put in 5, it's going to say hit false handler, value of 5. And so you now are aware of what a higher ordered function is. This is all that it is. It's a function that takes other functions as their parameters. And this becomes really powerful because in F#, the way we create more sophisticated programs is not with object hierarchies. It's not with inheritance. It's not with indirection. It is by taking functions and plugging those functions together to make more sophisticated functions. So any individual function in F# will often be a simple piece of logic. It's kind of what you're seeing here, where it's saying like, hey, I have some logic if A is greater than 10, and then it's going to call the logic for the true handler, else it's going to call the false handler. And so this gets to a really important design principle of F# that I generally try to follow. This is kind of my default way of thinking when it comes to when I'm writing functions. When I have a function name, I want everything I'm doing in that function body to be related to what that name is implying. And so in this case, what you're seeing here is that, hey, I'm only doing validation inside of this function body. And when I need to do something other than validation, I am calling a separate function. And so what I try to do is not mix the contexts of what I am doing inside of a function. Like, hey, if this is a validating function, all that function should be doing is validating. It can call other functions to do other things, but really at the end of the day, this is all it should really be doing. And if there's additional, more sophisticated logic that needs to be performed, that should really be another function that gets passed in, or functionality that should be moved somewhere else. And so that's why having the ability to pass in additional functions to deal with more complex logic that doesn't necessarily pertain to the domain of this function call is a great way to keep your concerns separated and make it easier to reason about what your code is doing and what actions are occurring where. Now, I talked about this idea of passing functions to other functions as parameters. That is one way of composing functions in F#. And you're going to hear this term composing kind of come up over and over and over again. Like in F#, we think about composition or composing things, or like plugging things together. If you haven't seen Scott Vlashin's talks on composition and functions in F#, you should go watch them. They are fantastic. But he talks about functions in F# essentially being Lego pieces, or things that we snap together in order to build more complex things. And function is one of those concepts that gives you a lot of mileage. Now, there's another way. So this is kind of one way you can think of composing functions, is I have a function, I'm plugging other functions into it. You can also plug functions in end-to-end, where you say like, hey, this function then, composes to the end of this other function. So like, let's talk about what that kind of form of function composition looks like. And so I think they're going to call this video like, function composition, because it's like different ways of combining and melding and merging functions. And so that's the idea on like the higher order function that takes functions. There's also what you can do is saying like, hey, let my first, my other adder, and this is A, which is an integer, B, integer, and I'm gonna say, hey, A plus B. Again, not terribly sophisticated, but like, hey, this is something that's an A, and then you add a B. And what happens if I have another section, which is let my multiplier, and I say like, you know what, this thing is just going to take, well, I'm going to make this even like my add 10. And I'm going to remove this B here. And this is it's just going to add 10 to it. That's all it's going to do. And let my multiplier is like, hey, this is also going, to take an integer. Again, I'm just being very explicit about the types here, just so it's easier for people to follow along. And it's going to take A and times it by 10. So, well, this is interesting. I have this one function, my add 10, takes an integer, adds 10 to it, and it's returning an integer. So it takes an int, returns an int. Int, int. I have my multiplier. It also takes an int. In this case, it multiplies it by 10, but then it returns an integer from this function. So you see integer to integer, and then integer to integer. Okay. What if I wanted to do both of these things? Let's say like, okay, well, I have let x equal to my add 10, and I'm going to start with 2. And then it's like, okay, well, I want to add 2 to it, but then I want to say, hey, my multiplier, I'm going to change the multiplier, and get that to result x. Because what I wanted to do is, I wanted to take 2 and I wanted to add 10 to it, but then I wanted to take that result and call my multiplier on it. And so now I'm having to do these 2 calls. And let's go ahead and call this to make sure that we're not going crazy, and this should actually work. And so this makes sense. So I passed into the result of x is 12, and then 12 gets passed into my multiplier, which multiplies it multiplies it by 10, so now we have 120. But what you see here is like, hey, I had to do that kind of in 2 steps. That's kind of annoying. I'd like to be able to just kind of do that in a single step. And I know that these functions are incredibly trivial, and you could say like, Matthew, just write a single function to like do that all at once. I'm like, yes, I know, but I'm trying to illustrate a point. And so I'm using very simple logic to illustrate it with. Notice int, arrow int, int, arrow int. So this is taking int, returning an int, taking int, returning an int. Who's to say the out of this function couldn't be the input to this function? Because like these ints are matching. Could we not plug this function into this function? Couldn't we compose these functions together? And this is the idea of like, again, that word compose, like, couldn't we put those 2 functions together so that the output of one is the input of the other? Like one immediately leads into the other. We could. Let's do that. Let my combo equal my add 10 composed with my multiplier. Okay. If I hover over this, it says my combo is int to int. What the heck? I'm gonna call it, and then we're gonna my combo, and I'm gonna call it with the same input I had before. Like, remember, I started with 2, so I'm gonna put all this into interactive. Say like, okay, you got my add 10, something that takes an integer, returns an integer. You have my multiplier, something that takes an integer, returns an integer, and now you have my combo, which is also a function which takes an integer and returns an integer. Let's call my combo. The result is 120. What did we just do? So what we just did was we composed 2 different functions. So remember at the beginning, we had the idea of a higher ordered function, which is a function that takes other functions as parameters to do more sophisticated work with. And that's one way of combining functions. The other way of combining functions is kind of gluing them end to end. And that's what this operator is doing. This is the composition, the function composition operator in F#. And what it does is say like, okay, if you have a function whose result type is the same as the input type of another function, you can glue those together. And that's essentially that's exactly what we did. It said like, hey, take my add 10 and glue it to the end, to the beginning of my multiplier. So when you call my add 10, I'm going to do what I do with it. So my add 10 is going to do its work, and then it's immediately going to take that result and call my multiplier with it. And so we have now made the my combo function by gluing the ends of these functions together. And we could do it the other way too, as well. Because again, like this is an int. Who's to say we couldn't start with my multiplier and then go to my add 10? So let my other combo equal to my multiplier composed with my add 10. That also works. And I can define that. And when I call it my other combo, I'm going to call this with 2, and I'm going to get a different result because the functions are being called in a different order. What's happening now is my other combo calls my multiplier first. So it's 2 times 10, which is 20, and then it calls my add 10. So it's taking 20 plus 10 and returning 30. So this is just kind of going to show this really kind of fundamental idea in F# is where we are able to use higher ordered functions to compose functions together by making functions take other functions as parameters. But we can also compose functions, which means kind of gluing them end to end so that when the output of one function matches the output type of one function, matches the input type of another function, we can glue the ends of them together to make an even more powerful function by combining other functions together. So I know that was probably a lot to absorb. These are the kind of things where if you're not used to the idea of functional programming, you're like, whoa, like what is going on? This is intense. I'm not saying you need to use this right off the bat. Don't feel like, oh my goodness, if I'm not using function compositions, I'm not a real programmer. I'll be honest with you, I almost never use this. It was introduced to me early on, but for the kind of work that I do, I pretty much never use function composition. Now, I might lose my F# card, like you're not a real F# developer, whatever. But I want you to know that it's there because you will likely come across something like this out there in the greater F# ecosystem. But that's all that's really going on is we are using functions and we're combining them together in different ways to create more powerful functionality. But don't worry, this is about as deep and as far as we're going to go into like functional programming in F#. From here, that's probably the most intense thing. And again, I don't really use it that much. High-ordered functions, I use them all the time, but they're typically functions coming from other libraries. I'm not writing them typically. I'm just utilizing them. And when we get to the F# collections, we'll be going into much greater detail with high-order functions because that's how we actually work with collections in F#. I hope this has been helpful. I know it was probably a little intense. There's probably a lot there, so I encourage you to go play with it. Go check out Scott Vlashin's material. He has done a fantastic job of giving presentations at conferences, and his blog is incredible, an incredible resource. And so, fast F# for fun and for profit. Every F# developer should visit there at some point. So go check it out. Something that would be helpful for me is if you left a comment saying like, hey, Matthew, this was confusing. Or, hey, I wish you could spend some more time clarifying that. Or other things that you would like me to cover or problems that you're dealing with. Because what I like more than anything is to help people with the specific problem and challenges that they are dealing with at work. So please let me know how I can help you. In the meantime, thank you very much for spending some time with me. It's been a real joy. I hope you have a blessed day. Thank you.